Hi there. Thought we'd take a look at this second order differential equation. Our first step in this problem, we're going to be verifying that the two solutions we're given, y1 and y2, are actually solutions of this differential equation. And then our second step, we'll go ahead and find the solution, the general solution based on these given initial conditions. So let's talk first about verifying. When we're verifying, we're proving that something is true. So let's prove this differential equation, second derivative plus 9y equals 0. And let's prove it's true for this first equation that y1 equals cosine of 3x. So the first thing we're going to do is we're going to take the first derivative. Now, the first derivative of cosine of 3x is going to be negative 3 sine of 3x. Don't forget chain rule here. So you're doing the derivative of the cosine, and then you're taking the derivative of the 3x on the inside. Now, once you have your first derivative, you'll want to go ahead and take the second derivative. So we're taking the derivative of the derivative. And that in case would give us negative 9 cosine of 3x. Again, don't forget your chain rule here. Once you've done the work here with your derivatives, you're going to be taking this differential equation and you're going to substitute in order to find out if it's true. So we're going to substitute into the second derivative plus 9y equals 0. We're going to substitute what that second derivative was, negative 9 cosine of 3x. And then we're going to have plus 9 and then the original y1 function. Now notice what's going on here. You've got negative 9 cosine of 3x plus positive 9 cosine of 3x. That's going to give you 0, 0, which tells us or verifies that this y1 is actually a solution to the given differential equation. Let's do the exact same thing for y2 here. So we'll take the first derivative and the second derivative. Now remember what we did before. We're going to substitute those into our differential equation. A second derivative plus 9y equals 0. So we're taking our second derivative, that's our negative 9 sine of 3x, plus 9 times the original equation y2. And we're going to show that that gives me 0. Again, we have that negative 9 sine of 3x plus a positive 9 sine of 3x, which is what tells us that this is, in fact, a solution to the differential equation. So that's your verify part. You've just proven that these are actually solutions, and we did that through some derivative work as well as some substitution. Now let's tackle this find the solution part, the general solution. Um, so the first thing we want to do is to take our differential equation, our second derivative plus 9y equals 0. We want to rewrite it as a quadratic. Think about that. I've got, instead of second derivative of y, now I've got k squared. You're going to think second derivative and the quadratic there. And then I've got 9 times the original function, so I've got 9 times k. Now you're solving a quadratic, so think factor first. Factors pretty easily so that we get that k is 0 and negative 9. Now you're thinking, what am I going to do with that? I'm glad you're asked, because you're going to take it and plug those values into this general form. So this general form, constant 1 or C1 e to the K1. Now that K1 is your first K value, and K2 being your second K value. So you're going to make your substitutions there. Notice 0 went in for K1, negative 9 went in for K2 into my general form. Clean it up just a bit because we know e to the 0 is going to be 1. So that just leaves us with C1 here. And then I can just leave my second term. Hope that helps you with this type of problem.